Hey everybody, the purpose of this video is to discuss determining the strongest intermolecular force, or IMF, a molecule experiences. Before we can discuss the strongest force that a molecule experiences, it makes sense to review our options. So there are four different types of intermolecular forces: London dispersion forces, dipole-dipole forces, and hydrogen bonding forces can exist both within a pure substance and within a mixture. Ion dipole forces, on the other hand, typically only exist within mixtures. Now that we know the different types of forces, or have reviewed them at least, let's look at how we might decide what the strongest intermolecular force is within a pure substance. I tend to take a flowchart approach to this process. Let's talk through that chart now, and then we'll work through the chart with a specific example. The first question that I like to answer is, does the molecule contain polar bonds? The easiest way to answer this question is to have in front of you a correctly drawn Lewis structure. If the answer to that question is no, then the molecule is nonpolar, and the strongest intermolecular force experienced by that pure substance is London dispersion forces. However, if the answer is yes, the process is slightly more complicated. We now have to answer a second question, which is the molecule symmetric? In order to answer that question, we not only need the correct Lewis structure, but we need that structure drawn in its proper shape so that we can identify whether or not the molecule is symmetric. If the molecule is symmetric, then the molecule itself, that means, has no net dipole moment, and therefore the molecule is again nonpolar. This means that the strongest intermolecular force the molecule can experience is again London dispersion forces. The alternative path is that the molecule is not symmetric. And if you have a molecule that has polar bonds and is not symmetric, it will have a net dipole moment. In other words, it will be a polar molecule. And now we have question number 3, which is there within the molecule a hydrogen bonded to an oxygen, fluorine, or nitrogen? Again, a well-drawn Lewis structure helps us to answer this question. If the answer is no, then we simply have a polar molecule with the strongest intermolecular force being dipole-dipole forces. Dipole-dipole forces. However, if there is a hydrogen bonded to either an oxygen, nitrogen, or fluorine in the molecule, then we have a polar molecule whose strongest intermolecular force is hydrogen bonding. Hydrogen bonding. It is a good idea to look at this chart not only through conversation, but with an example. So, let's do an example. Let's say, for sake of argument, that we want to understand the strongest intermolecular force in hypobromous acid. Hypobromous acid, HBRO. If we draw the dot structure of hypobromous acid, we will get a structure that looks similar to this. Oxygen in this structure is in the middle, even though it is the most electronegative element, because it is the only element in this group that can form a bond to two different elements. The molecule itself has a bent molecular geometry and a tetrahedral electronic geometry, which will become important in a second. The first question in our flowchart about this molecule would be, does the molecule contain polar bonds? Well, the hydrogen-oxygen bond is very definitely polar, as is the oxygen-bromine bond, so the answer here is most certainly yes. So it does contain polar bonds. The next question is the molecule symmetric? Well, it's a molecule that has 3 atoms in it, that has a bent geometry, and all 3 atoms are different. So no, the molecule is not symmetric. It is not symmetric. Even if we draw it in its actual shape, because it has 3 different atoms, it is not symmetric. That means that we have a polar molecule. The last question that we have to answer is, within this molecule now, is there a hydrogen directly bonded to an oxygen, fluorine, or nitrogen? And based on our Lewis structure, the answer is absolutely yes. That means that the strongest intermolecular force that this molecule can experience is hydrogen bonding. Hydrogen bonding. So hypobromous acid, strongest intermolecular force will be hydrogen bonding. So that was determining the strongest intermolecular force in a pure substance. What about if we have a mixture? There are 4 statements that hold true for a mixture. First, if at least one of the substances is nonpolar, then the strongest intermolecular force in that mixture is going to be London dispersion. If both substances are polar, but neither has a hydrogen bonded to an oxygen, nitrogen, or fluorine, then the strongest intermolecular force is dipole-dipole. However, if both substances are polar and at least one has a hydrogen bonded to an oxygen, nitrogen, or fluorine, the strongest possible intermolecular force is hydrogen bonding. Finally, if one substance is polar and one substance is ionic, the strongest intermolecular force is typically ion dipole. I hope this video provided you a little bit of guidance on how to select the strongest intermolecular force in both a pure substance and a mixture.